Hello, hello. Ah, let me fix that. Just a little bit over. How's it going, everyone? Today we are, fingers crossed, going to be finishing up some WGPU plus shader work that we've been working on for the past few streams. To sort of recap and summarize how this all ties into what we've just sweeping arc of things that we've been exploring. The WGPU crate is a way to implement shader or more GPU focused code. It is a Rust crate, and one of the things that it can do is create a distributable called a WASM file. And that file can be loaded into the browser. So I believe all the Evergreen browsers have support for WASM. Within that file, WGPU now has, I think they've supported it for a little bit now, but they have the ability to handle multiple APIs, one of which is the WebGL, which is sort of the older API. And the newer one is WebGPU. So that's what we've been experimenting with, that specifically. And we're on the back end of it and playing around with shaders and seeing how we can create a shader and load it into and get it to show up in the browser. We have one of their examples. We pulled it in and like stripped out pieces that we don't want to worry about right now, and got it working. And we're working on tweaking and pulling in a new shader and seeing what that looks like. Now, where all of this wraps in is that this crate can be used within a desktop app as well. This could be something that you could use, and as a lower WebGPU specifically is like a lower level library that's used by other Rust crates such as Bevy, to basically create like a game engine. So like the WGPU is a lower level library that higher level libraries can build on top of and sort of abstract out some of these more verbose APIs. And all of that ties back into WebGPU, and it being in a desktop app starts to sprinkle into how we think about and put things together in Tari. And I think we'll leave it at that. I personally want to experiment a bunch with WGPU and web views and how they can interact. But there's main thread issues, and you can only have, I think you can only have one main thread, or the web view expects to be the main thread in a window. So yeah, that might be something we experiment with, and the lower level creates within Tori as well. So I suspect all of this is going to start tying together as we kind of continue down this trek of exploring the lower level libraries. But anyways, today, shaders. Let's flip over to it. The thing that we were working on was we have this we have a compute and a draw voronoi, and the compute and draw were the previous shaders, and we're trying to swap out those shaders from something that we found on Shader Toy, and likely going to make adjustments. But just understanding how like a shader or something that you might see in Shader Toy, how that maps and is how we can take that and shift it into something that can be used within WGPU. And that specifically, you might have seen in the title, Naga is a library that WGPU is using or built on top of. that crate is also put up by the same group that's working on WGPU. And that's that can handle conversions between different shader types. So right now we're looking at WGSL. I think Shader Toy writes in, as far as I can tell, GLSL. So, I just noticed, is this chat not working again? Well, action history. Let's fix that real quick. I don't know why it just struggles with like disconnecting and reconnecting streamer.pot and YouTube. Oh, okay, I guess I didn't. I just had to click sign in. We'll try auto connecting. I've had issues with auto connecting in the past. I should also, there we go. All right. We're gonna not on stream, but I think we're gonna give that some attention here in the very near future. But I'm still like setting up and configuring the computer. You can see I don't have dark mode on. I haven't actually activated Windows yet. Priorities. I don't need to activate to use the computer, but I think it's getting to be that time. All right, so let's go ahead and get our shader running here. And it was cargo run WASM package voronoi background. So the idea is that we're going to ideally make a shader that we can use to replace that background. And we're going to we're gonna do that. The intention was to make something that worked in the browser and WASM, and then pull that in as a browser source within OBS. So OBS can basically show web pages. So shout out over on, I think they stream mostly, well, they stream on Twitch, but I think they're mostly on Twitch. I don't know if they have a YouTube channel, but there's somebody on Twitch called Finite Singularity. Pretty cool person. Go check them out. They've done a bunch of stuff with shaders, both recently and in the past, as far as I've ever interacted with them. And they've got a pretty nifty stream, and they do all of their, I believe they do all of their shader work in OBS, which means that you can have sliders and interaction within OBS to change that, which is interesting. But I think it would also be really cool if we could get chat to interact with shaders here. So putting it in the browser, we have an overlay which would allow us to pull in the shader work and put it in that overlay. And that overlay is hooked up to streamer.bot, which gets chat events. So the question would be, could we get, I think we'd have to do WebSocket within our WASM to make that happen. I don't know if it would make sense handling that in JavaScript and like passing off messages to WASM or not. functionally or like performance wise, I don't think it probably would make that much of a difference, but that might be easier to handle within the WebSockets, or the WebSockets within Rust. So something to think about. Something to think about. It would be cool though. That might be something that we explore further on, and like in how we end up like working with WASM and doing that, and if it makes sense to communicate over that JavaScript to WASM bridge, especially in the context of a Tori app, because now you have JavaScript and WASM and Rust, so potentially Rust in two spots, sort of the like backend behind the scenes layer, but then also the front end of the UI has both JavaScript and WASM plus CSS and HTML and such. But potentially, I guess theoretically, you could do everything with shaders. Anyways, distractions aside, I thought I just got a message. Let me just double check that real quick here. The reason, why are you misbehaving? The reason that the stream is slightly later than normal is I had a meeting. And it's actually a good thing because Elgato was kind of giving us issues here too. I don't know why, but like my Elgato, I've got an internal PCI card now from Elgato for you being able to see me. It just like doesn't show up, like it disconnects itself, and restarting the computer doesn't always work. I tried turning off fast boot on the computer, which sounds like it might be potentially an issue, but computer stuff. Anyways, distractions. Let's get checking with this. So last time where we were at was that we dropped in these shaders, we started loading them. We have compute and draw voronoi. We have, I'm not sure why Rust Analyzer is working now. I've had this open for a little bit now. And I think all of this is going to be fine-ish to not deal with at the moment, because all we really care about is the render and the compute passes. A bunch of this particle stuff, it'll be like passing in values, and I think into the shader that I believe we can use, like vertex buffer data. It'll be nice to figure out how that works and how we can pass in data, but I don't really need it right now, I don't think. So as long as we get it working, and what we were iterating on before was and actually I had a separate idea on this too, but what we were iterating on was specifically getting this shader rewritten into WGSL, which is slightly different, similar, but slightly different enough where like we've ended up having to go through everything line by line and like get things updated. All right, I gotta turn down this music a little bit. Yeah, you can see it. Let's see, music. It seems like it's good for y'all, but it's just a bit on the loud side for me. There we go. So the other thing that I was thinking of after we ended the stream was that we also had installed Naga, and we were trying to use it before with, why does this feel like it's really small? We were trying to use it before with the .comp, which was the way I understand the shaders is the WGSL, you could have you like notate like what pass, like what draw pass this thing is for. With GLSL, that's separate, and the file, but when you give it a shader to run, you need to like specify what like draw face this thing is under. And the .comp is one way for that people help separator, like the I don't think the file name actually matters. Don't quote me on that. But I don't think the file name actually matters. But .comp is a way to communicate that this is a compute shader. So we were trying it specifically on this, and it was not working. But now that we've started rewriting things, we have a shader. Which one were we looking at? It doesn't specifically say. We have both a draw and a compute. I think we were working through the compute. And this is now written in WGSL, which is supported. So I think we might be able to use Naga to help us out here. And I think within Naga, there's also a way that we can watch, which would be very helpful rather than have like a reload and rerun every time. Entry point, version, standard flow, help, validate. I thought that was a watch. Input, standard in. Maybe not. Let's just try going for it and seeing. Yeah, unrecognized target. Okay, that's fine. Maybe we could just keep rerunning it. I believe this is going to end up giving us a better workflow than having to like just refresh this continually. We're going to try to iterate through this and fix all of these issues. And it actually seems like this is going to give us better information on better information on how to deal with this. Oh, we're redefining. Oh, interesting. Why are we doing that? Oh, times existing. Oh, that feels awkward, but that's fine. The type of R is expected to be vec, but we got a different type of vec. So there's F32 and I32. F32 is float. I32 is assigned integer. Integer signing refers to the sign or the minus or the lack of a minus sign in front of the number. So if you have an unsigned integer, your numbers are only going to be able to increment like in one direction. So it's going to be only positive. But if you have a signed integer, you can increment in both directions up to the 32 part of that data type, which is, I don't remember offhand. I would have to look it up, but it's not really worthwhile. That signifies how big the amount of data you can fit in there is. So there's like I16, I32. I think there's I64 and 128 maybe? I think. I32 and F32 seem really common though as far as data types that I've used for stuff that I've been working with. Okay, so R is expected to be an F32, but we got an I32. Which might be fine. Because if we're adding a G and an O and a G, so O should also give us a, oh no, hash is gonna give us a float minus F. I don't know about that. Nope, that's definitely a vec2 F32. I feel like this needs to be an F32. It seems like there's not a way to... Oh. Like it seems like there's not a way to like force it to change data types. I mean, we could probably do something. Can we do something like r dot as... You're not gonna help me out at all? That's a bummer. Oh no, I'm totally in Rust. I'm running a thing and I'm getting decent errors. It feels very Rust-like. Yeah, this isn't Rust. Awkward. Anyways, I guess we just keep making stuff I32. It's expected to be I32, but got I. Oh. So it is an I32. What did we have there before? I don't remember. MD is mutable binding, so they're mutating again. MR, same deal. MG, same deal. Line 56. Oh, this is so much faster. So we're back. We're down into this area, which is gonna probably end up having to be very similar as far as the changes that I do. It's expected to be an F32, but we got an I32. So go for it. O needs to be mutable. R needs to be I32. Okay. Ooh. Naga, valid expression left, function arg of type vector. Naga, valid expression right. So we're saying left and right here. So if this is an expression, this would be the left side of the expression. This would be the right side. The right side is of type vector, size bi. Float versus cent, and width appears to be the same. I don't know what width refers to. But what it's trying to do is take and calculate a okay, this is in the hash. Function hash 2 is invalid. Expression 3 is invalid. Operation add can't work with 1 and 2. So where would be 1? Oh, nice. They got them named. This is very helpful errors. 1 and 3. Okay. So that would be, I'm guessing 1 and 2. Operation add can't work with 1 and 2. So hash is invalid and expression 3 is invalid. So both of those are invalid. We do some addition. So like, that should be fine. If we say let that, okay. Do we always need to define the type? Maybe. The type of P is expected to be this, but got that. So we're expecting this to be an F32 when it should be, we're expecting it to be an I32 when it seems to be an F32 because we're adding two F32 together, I guess. I guess that makes sense. If we take a integer and a float, we should get a float. All right, what do we got? Same issue. Why would those be? Let's break this up can we break this up? I assume we can do something like this. We've got a vec2 of dots, and the dot is taking this like hard-coded vec2 times p. Yeah, so we do want to add those beforehand. It's possible we could do something like this. Let's just see what happens. So it doesn't look like that either. I wonder if we can like, oh, I went too far. I've gone too far. I wonder if we can do something like, we're fine parsing this or casting this as a float. Expected expression. To the internets. We want to take a WGSL integer as float. So this does not look like. Oh, okay. Vec-n is supported, but I32 as an input is also helpful, for example. Okay, so dot supports both float and int in HLSL, but only float in these. So converting from integers to floats, then doing the competition. Yeah, that makes sense. So it's not really helping us out at all here. But it does seem like what it's saying is that, hey, this is not valid. We can't actually do addition of those. And this is GLSL. This float. Let's say WebGPU. It doesn't seem to pick up very well on the WGSL. I get a lot of results that have GLSL. As I say this seems like it actually might be helpful. So we can change the type of expression. So is there a cast? Can we cast? They're saying cast I32. Who knows if this actually works, but let's give it a shot. Cast. That seems to be fine. Let's just take this off and see what it complains about. Yeah, unknown identifier. Okay. So it seems like there is it doesn't seem like there's any way that we can actually make the conversion. So how do you deal with it? What is the equivalent of GLSL's uint bits to float? Oh, ho 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 ho. Bitcast. Bitcast. Oh. Yeah, it's a... I'm assuming they're called functions in here. Hey. Cool. What do we got now? Add can't work with 38 and 37. So expression 39. So that is invalid. And this is on line 39. So, well, now that we know about that, we might end up going back through and converting and keep everything in floats. Does that make sense? So this should be a float sign. We're gonna say .0 just to make sure that is a float, and it's going to add, can't hover. I'm assuming sign is a, oh, I definitely put in the time. This could very well be an integer. Let's look at the original shader toy implementation. O is supposed to be a hash2, and the hash2 is returning a vec2. It's doing an add of n and g. And they look like they're supposed to be floats. So if we take, so in here we're bitcasting it. So this should end up returning a float. So we should have a float here, and we're doing a float times this. And it's saying, can we confirm that? Left of type vector, whatever sent is. On the right is binary. Okay. Kind float. enter left splat, right binary. I'm not quite sure what that means. Definitely not 100%. Expression 39 is invalid. Oh, I just erased line. It's saying that line is invalid. Oh. 39. Oh, R is invalid. Oh, yeah, I changed that. There we go. So I actually fixed that previous error. Just without actually realizing I was fixing the error that I was looking at. Okay, so we have a G, an O, and an F. G is going to be a vec of I32. O is going to be a vec of F32. And this is where we start to run into issues, because then F is F32. So I think what we need to do here is we're going to say F. We're going to say F. N and G, so that's already going to be a float. So if we say G is going to be F, and we have an N, and what we can do now then is bitcast these into floats. And I think we're going to have a better time with that. I'm going to change this one right away as well. Bitcast these and that. Bitcast, bam. Hash 2, this is also going to need to be that. So now we're working with a bunch of F32s. Our R should be F32s now. And a dot product of an R by itself, guessing, is also going to be an F32. So let's see where that gets us. 57. Bitcast J. So J is an I32. Both I and J are I32. And it's saying the type of G is expected to be a vec of F32. But we got a vec of I32. We're supposed to be bitcasting them. And we've got an I and a J, which are both I32. MG is going to be a vec of I32. Oh. So I think if we change this, that seems questionable. Let's look at the implementation again. We are defining an MG and an MR. Vec MG MR. Okay, so we're not actually like assigning it anything. So this is like an undefined. Which I don't know. This might not be the way we want to do it, but that's something to do. Ooh, validation successful. So let's go ahead and run. Let's see if we actually get something showing up. We'll refresh. Render pipeline is invalid now. Not particularly surprising. We were working on the jaw. So now if we go back to Naga and we say, instead do the compute. So both the compute and the jaw are validating. So That's something at least. Let's go ahead and refresh. What does the error in here say? Vertex attribute slot 3 was used in shader model, but is not present in the vertex state. Ooh. Nice. Too many errors. We're going to just we're just gonna exit. That's kind of funny. All right, so vertex, we can make this a little bit bigger. Vertex attribute slot 3 in shader module. So it's looking at entry point VS, or excuse me, main VS, which would be this one. Because I think our compute is just main. Looks like it. We've designated it as a vertex, which is the shader type. Shader pass? I don't remember. Hey, we went right to it. The shader stage, that's the word. Vertex fragment compute. Vertex and but before we were talking about the .comp or .comp compute. That's a way to signify to mostly the people writing the code to use that shader that it's a compute shader. But the way WGSL works is that you have these directives and you can signify this as a vertex shader. So we might actually, can we put them all into the same? Something to think about. Okay. I don't think we can put them all into the same shader file. At least for how we're handling it. Because we have different, we've got a shader pass and a compute pass. Or render pass and a compute pass. That's maybe the better way to say it. Okay, so we have a vertex state and we have a slot 3. So it's saying that, I'm guessing it's referring to this. And it's saying that that doesn't exist. So we need to probably go back to this and say, when we are handling the, is this the draw? So when we're handling the draw shader, where is that picked up here? Let's move everything over here. Come on. Let's go close all the examples. Compute, draw, compute, main. There we go. The draw shader shows up in the render pipeline. The render pipeline has entry point via main VS. So that's looking like it's matching up. Vertex state. They called that out. Is not present in the vertex state. Attribute slot 3 was used. So it's using attribute slot 3. So if I'm presuming this is a 1, a 2, and then there's a 3. So we have a vertex buffer layout. And then the same again. Well, similar again. It's expecting 3 vec2s of F32. We have two. And then there's a fragment state. So if we look at the previous example, so the vertex stage is main VS, the fragment stage is main FS. Fragment is just returning sort of, it looks very no-oppy. I'm not 100% sure if it actually is. We are also doing that. It's expecting these three things: particle, position, velocity, and just position. Here the entry points still match up, so I think we've got those right. It's interesting though that we've only got 2 in here. I would have expected to see 3, which could be very well what that error is trying to signify. I'm not 100% certain why. Like if we go like that, is this going to change our error? Kind of wish this would rerun. Over there. Attribute shader location 2 is used more than once, so it did change it. Oh, 0, 1, 2. So our draw, we have an X, which honestly, like position, can we just do, rather than calling it X here, can we just say like position.x? So position is maybe. Oh, gotta restart this. I'm not sure. So it looks like we are passing in a vertex buffer layout. Not certain what array stride is, but they do differ between these two. In here we are doing a particle position and particle velocity, so we have a specific buffer for that, and we're saying, hey, 0 is an F32. Oh, okay. So we have an array of 4x4. This I'm not 100% certain on this, but that's how I'm reading it. And we're saying a float 32 by 2 of it is going to be 0, and then the other part of that matrix is the 1, and those end up mapping to position and velocity. So I think if we only cared about position, okay, we got difference. Cannot initialize let of type vec32 with a value of type f32. Ah, okay. Nice. So we can get rid of this, and we can get rid of this, and we're going to say, we're going to still say location 0 here, and I'm going to update this to be 0. I think that is still going to work if I'm understanding this correctly. And we should be able to refresh and get the exact same error. Yes, okay. So it is saying that n should be a vec2 of f32, but we're just returning an f32. That makes sense. N and f, what are they in here? It says it's a vec2. Where is n used? This could very well be like a kind of shorthand syntax where if you only give it one value, it only fills in like the first of the two. So it might end up being something like where we want to do this. We'll rerun and refresh. What are we working with now? No errors. That's good. That's good. But clearly we have nothing rendering. So presuming we're correct on this, the vertex and the fragment potentially are working. So if we go over and look at our compute, that's still all the old way. So the compute shader is still doing all of the old things. If we bring over I think we're mostly looking at doing like this. And some of these are going to be very much like, I think frag color is a shader toy specific thing. So we're going to need to make adjustments for certain. I'm going to go ahead and remove all of this. Particles DST. Do we have a... So it can return... I'm not 100% certain what this is, but it says var storage, read and write, var uniform. So it's possible that this is like writing back and forth to local storage. We have this in a separate file, or we can always just refer back to the examples on the website. So we're just going to go ahead and delete it all. And let's just clean this up a bit. And we are going to say, let this be a vec2. I have no idea what it's going to be. So TBD on that. Based on everything that we've been doing, I think I'm going to run with an F32 and see where we head from there. This is running a... That is referring to the other function that we have, that vertex state. So that I don't think is going to actually work as we're expecting it to. And it's looking like... We've got a few things in here that I think are not going to work like we're expecting them to. So let's just take a look quickly at the compute and how that maps up to so the render pipeline takes a vertex. So I feel like we have all of this matching up pretty good. The fragment shader, now that I'm looking at it, the fragment shader is returning a vec4 of all ones. I believe the fragment shader is what's controlling the background color. So we very well might not need that. Render pipeline, is that used later on? So that's returned in the example struct. And so color attachments, render pass. particle buffers and vertex buffers. Okay, so in our render pipeline, we are only doing one vertex or one buffer now. So this render pipeline is going to I believe kind of make itself shown here in the render pass. Command encoder is beginning a render pass, setting the pipeline, and then setting variables. So here we can see slot, render DST particles, and then 3 instance local variables. We have a slot 0 and a 1. And this is probably why it's not actually drawing as we're expecting it to. Because we're setting a vertex buffer for slot 0 and slot 1. So the position now is going to be this. We're not actually doing the particles anymore. And that is referring to bounds. And bounds is, that tells me that it's positional. Vertices 0 to 3, instances 0 to number of particles. Yeah, sure. Let's see what that does. Okay, particle buffers is never read. So if we look at the example, particle buffers is never read. We can get rid of these, and if we get rid of, in the example struct, particle, because we're not going to care about those right now. And that was just dead code. So we didn't actually need to address that error, but by removing that, we can now go back through and say, okay, well, here we're also doing some stuff with the bind group. We're actually going to just comment that out for now. I think I'm going to need potentially something with the compute. Okay, so well, I guess this makes sense. We're on to the compute shader errors, which tells me that we updated this in a way that it's actually like trying to render and it's hitting that compute pass. Which now, if we take a look here, what is it trying to do? It is gotta got a message. ISO lines, borders, and feature points. So feature points, I don't think I really care about. I believe feature points are those like little dots moving around in the middle. I don't know if we need to. I don't know if we actually need to worry about those. But also in this voronoi, it is doing. It is literally calling that. So we have a vertex, a fragment, and a compute. Compute shader stage in the compute pipeline. So fragment and vertex are render pipelines. So when we have marked these as vertex fragment, and we have addressed these in the render pipeline. I think we've got all that hooked up correctly. Just as far as like mapping those to those. Now the question is, we have this, which has a function and then another function leading into this last thing. Now we have 3 stages. I wonder if actually could this all be a compute shader? I'm gonna remove these just because I'm looking at them. And our sim parameters are likely also going to change. I'm wondering if we actually want... So frag color and frag coordinate are shader toy things, I believe. Let's look at these. So the compute shader is calculating. Compute shader is calculating the position of a thing. So we have a particle, the position of that specific particle. The draw is going to be drawing something around that. So if we have we've got a vec2 and a vec. I'm gonna change this before I forget about it. A vec2, which is designated as P, which is fragment coordinate. Oh, fragment coordinates. That makes sense. Okay, so the main image is going to return a fragment color and a fragment coordinates. Now, if we say dd, what is COL? COL is going to be the X position of this. Okay. I think this is all around the particle. So it is using the X and then the Y and the Z, or the YZ rather. This is figuring out the point. So like if we just go through here and we try to do one single piece, what is this going to look like? If we say let dd be an f32, length is cyz, this is returning a vec4. Vec4 is made up of an MD, an MR, and a 1. MD and MR. So we're going to have something like 8, comma, whatever MR ends up being, comma, 1.0. And that's how we get a vec4. This is what it was in there previously. So position and particle position. So position ends up being 2 values. So this is going to return a... It's going to return a vec4. Which is funny because we get a... Oh no, it is returning a vec3, okay. I kind of wonder if, so if we have a particle and we're computing the location of the particle, it's moving around. Now if we take a fragment shader, we can make that particle look like a triangle. And we can choose the rotation of that triangle based on the velocity of said particle. That gives us a compute shader for the position of the particle and a fragment shader for the position of, or for the, to draw the triangle around and determine the rotation of the triangle. And then a fragment shader to do the black background. Now in this case, if we go back to just the original code here, we have fragment coordinates and fragment color. So is this full thing this full thing could basically be a fragment shader? So if we look at the about, no, too much abouts. Documentation. Image sound VR input. Image shaders use the main image function to generate images by computing a color for each pixel. Frag coordinate contains the pixel coordinates. They're in pixel units ranging from 0.5 to resolution minus 0.5. The resulting color is gathered in frag color as a 4-component vector, the last of which is ordered by the client. The result is gathered as an out variable in provision of future addition of multiple rendered targets. So is this strictly a fragment shader then? Do we actually need to do any compute? So if we take a look at this again, we have a main image. We're getting the positional data. We're computing in a voronoi, and then we're drawing things. So based on mixed length and frag color. So what's COL? I guess, oh, that's using the color. Okay, so the color, I mean, if COL is supposed to be color, I don't understand what saving 2 letters is gonna help. So P is going to be determining the position. P has got to be position. Is it using position anywhere? No. It's not actually using position directly to draw or locate a particle itself, but it's using that position to then draw the actual shader itself. I think we could do everything with a fragment shader. In which case we won't have a compute pass. It's strictly going to be vertex. I think that's good. I think we're fine with that. I think we can make this conversion. I don't think it's gonna be too involved. Let's uncomment out these. Oh, actually, you know what? I don't want the original compute. I want this. So it's not actually a compute. It is a fragment shader, I guess. So this voronoi ends up, this is technically all vertex stuff, right? Or are we strictly fragment? Are we strictly fragment here? It's because it's not a vertex. A vertex would be a triangle. I think we're strictly we're strictly fragment. So if we go fragment, we don't actually need this anymore. Okay. Oh my, this is gonna be a lot. So we have a vertex and we got a fragment. If we get rid of this and move the buffers into here, I don't know what the targets is doing. Config view formats. Okay. So if we say, well, we want location 0 in our buffer thing to be position. Right now we've got and that's going to return a location 0. That reads weird to me. I mean, that's also going to change, but so if we say, well, this is just going to be a function called voronoi. It is not a vertex. It is going to need a location. It is going to be passed in though, and that is going to be this. So position is going to give us vec32. And we're going to return a vec3, I believe it was. Yep, a vec3. And I think that's all going to work there. We're going to remove this as we don't need this anymore, and it is now a vec3. So I think that tracks better with what we were trying to do. Our fragment shader right now is just returning a black background, but we want it to return basically this. And we are taking in the position. The position isn't going to be determined there. And I think we just pass it in position. So that is going to give us a basically 8x multiplied vec2 of floats. And this fragment is then going to return a vec4. And our vec4 is going to be F32. And we don't actually need frag color. We're just going to straight up return. And that is going to be so color. We're going to rename all of this to color. And we're going to say var color is going to be in vec3 of F32. So we're going to get a vec4 back, which matches up with our previous return. We are let's change the C. We're gonna say I mean, it's not scaled. Voronoi position. And this is going to be a let. And it's a vec3. Vec3 of F32. So yeah, okay, that feels good. I'm not sure about the smooth step. That may need to be changed. We have a vec3 here. And so all of these vec3s here need to say F32. Ooh, boy. F32, as does this. I don't know if the shorthand syntax is going to work right there. You might need to say 1, 1, 1, or 1.0, 1.0, 1.0. Just because I feel like this reads a little bit easier, and is clearly, it does not have an automatic formatter in there. Ooh, let's see what this does. This is now something that we can just test directly again. Okay, float DD on line 79. So this is going to be a let F32, I guess. Unknown identifier. No definition and scope for identifier voronoi. So we're saying voronoi. If I could spell it right. There we go. Unknown identifier. This needs to now be the C is voronoi position, I believe. Validation successful. Okay, we'll run that. And refresh. Let's see what we're doing. So this is still vec3. That all looks like the compute stuff. I think we can rip out the compute stuff. We're gonna go for it. And we can always like build it back up. The compute pipeline I do not believe is actually needed anymore though. We're gonna go backwards, and we have 2 passes in our render. Color render command encoder runs the compute pass. Render voronoi. So if we just comment that out and strictly just run the render pass, let's see what happens. We'll rerun this. We'll pull this and refresh this. Okay. Still not liking it. We have some dead code notes. Let's just rerun it again just to make certain. Yeah, and an empty cache. Okay. Entry point VS does not exist. Okay, so that's definitely an issue. We need to do in our render, or excuse me, in the render, we don't have a vertex anymore, so we're just doing the fragment. But we might need this buffer, and I don't know if I could do this. So vertex state is missing buffers. Fragment state has no field name buffers. Do we need it though? I don't think we actually need it. Let's take it out. Again, we can always go back. We can always go back and check it. Missing vertex. So can we do like a vertex and just no op? Vertex state. This corresponds to WebGPU vertex state. Copy. So if I just try to open it up, it's going to open up in a different browser. Oh, I don't want to look at that. I want to docs. So we are in the create render pipeline. It expects, or it creates a render pipeline, and it is taking the descriptor of render pipeline descriptor, which is what we see here. So vertex state, the compiled vertex stage, its entry point and input buffers layout. So we can do that. And now do we have? They really don't have any. They don't have any docs on it. So let's see, fields, label, layout, vertex state. If we go look at that, describes the vertex processing in a render pipeline. I mean, that's fine. I don't think I need it though. So let's just double check on examples. Here we go. If we look at like cube, this has got one. So vertex, fragment. So it does have a vertex and it has multiple fragments. And if we look at this implementation, we have some functions. We have an init. We create some buffers and then a binary group layout. And then the pipelines and our render is okay. So it's specifically the render pipeline that I want to look at, not the actual render. So here, there's a vertex state. Let's use this new search. I think it's I'm not signed in. Yeah, it's fine. It's fine. We'll just look at another one. Let us let's see, render bundles, cube maps, storage. So I think what we figured out that we can, while we're writing these shaders, it's likely that we're going to end up wanting to put our fragment and our vertex together. I suspect I'm not going to get any more complex where it makes sense to separate those out, but that's how it is. What's this hello compute do? Good, not much. So this is a compute, and that's it. Do we have a hello triangle? That's gonna likely have a vertex, I'd imagine. Fragment and a vertex, yep. So do you need both? Conservative raster. It's got a vertex as well. Vertex fragment. Guessing that this is gonna have a vertex, yep. Well, boys, is what we're looking at. Skybox. Skybox has a, and you can do structs in here. Interesting. Interesting. I am thinking that I'm going to want to dig into Naga more and how that works, because it seems like it would be very helpful for like testing these things out. I can't find any examples though of. Oh, that's the common stuff. Like, what does just a raster look like? Ooh, capture. Oh. Interesting. Interesting. This could be very useful for other things that we want to do. Very interesting. Texture arrays. So this is for text as well. Let's look at their examples. Maybe we can just pick it out from there. See if there is anything that, so skybox, definitely not that. I'm guessing this is gonna have a vertex because it's just a triangle. Hello compute isn't doing anything. Okay. So that didn't help. Bunny mark. So what does it look like if we do, I mean, all of the, like this has to have a render pass, right? So we're doing a render pass here and we're setting a pipeline. The pipeline is set up here in that struct. This has a texture and here's a pipeline. So the vertex. So it just sets no buffers and it's referencing shader. And shader is, okay. So maybe that's all we need to do. This is the way to no op effectively. So like this is the shader that we care about. And you'd look for VS main, but it's just not gonna be there. Is that like the expectation here? And refresh. So VS main doesn't exist. Which is fine, but why does it work in this one then? And so shaders coming from okay. Let's see. If we say WebGPU, or maybe we just do WGPU. Do you need both a vertex and fragment shader? This is where we were before. So vertex, this sets the color of the current fragment to brown. Makes sense. Now we can save to out, and then we just return out, and we're done with the shader. Okay. So we have a vertex. PS main. We're just gonna try this. It's not what we actually want. But I'm curious, if we just have something in there, what are we gonna roll with? Can we get anything to render? Render pipeline is invalid. The component count of 3 at location 0 is different from the component count 2, the fragment input. So our fragment input is 0 position. The issue is that we're doing a fragment there. I mean, do we need to? So like if we render just like a simple dot or something like that, is that going to be sufficient for the vertex? So we got a, I mean that, interesting. So well, we definitely can't copy that. Let's deal with that first. So if window is that, then X and Y of clip position would be between 0. Okay. But if you want to know the position coordinates, you have to pass them in separately. Which is that other piece. So the location. Okay, so you can do a struct. That's kind of nice. Now, if we are still getting errors for other stuff here too. And we don't have that in here anymore. Let's just clean up some of this particle stuff real quick. Compute. I don't know if this ends up being used. I don't think we're gonna need that buffer. find out, I guess. And compute pipeline and compute pipeline. So if we don't have any compute pipelines, what are we looking at? We're doing some more math here, but like, and then we can, let's get rid of this. Let's just see if we can remove all of the errors. Yep, we got some dead code, that's fine. Okay, so now we're just down to that single issue that we were looking at before. Invalid render pipeline is invalid. Nice. The component count of vertex output at location 0 is different from the component count 2 of the fragment input at location 0. So we are inputting I'm still not sure on this. Set vertex buffer. Let's just comment that out for a second, just in case. Actually, no, that might be an issue. Because now I think we're gonna go back to that other issue there. The VS main doesn't exist yet. So we'll leave that in for the moment. Our render pass is going to, it takes a descriptor and a pipeline, and we're going to do 3 instance local vertices. We have changed this. So for slot 2, or for slot 0 rather, we're doing that. And we are looking in our fragment. Because we're not doing any of the thing with the vertex buffer right now. So let's, if we just straight up draw, what are we going to do? And if we do nothing with VS main, I don't know if we actually need to set an output or not. Let's go back to that. This would be in draw, I guess. The return here is this. It's not actually what we want. But I think this is going to give us a better... Yeah, because this is using a bunch of locations and stuff. So if we just say like a bunch of... This is vec zeros. Vec 4 of zeros. And we do something like this. What are we going to be looking at? Because I kind of just want that, oh, no op. Entry point VS main doesn't exist. Main VS, main FS. It appears to exist. I'm looking for... In my copying and pasting, my entry point was renamed. Okay. Rerun. Do this. Do this. The fragment input at location 0 doesn't have a corresponding vertex output. Got it. And that is because we're looking at doing this. But I don't think we actually need to like worry about doing the built-in stuff. Missing entry point IO attribute on return type VS main. Oh, okay, so we do need something about that return type. Mikey, please stop. Every time, every time. So it's, yeah, it's doing stuff with the position. Let's go to WGPU again, and let's just say, in here, do you need a vertex shader? Yeah, this is gonna all be. Do you need vertex shader? Because I really don't think we have to have one. Yeah, like, see, there's also instancing. So, like, here's a render pass. We're setting the pipeline and then we're drawing. 0 to 3, 0 to 1. The render pass is doing color attachments. And that's doing a begin render pass, which is what we were seeing. Down here somewhere? Command encoder. So there's a queue and a frame count, and then, yeah, begin render pass. So our pass is this begin render pass. And it does the set, yeah, so label and then color attachments. And it's just part of this command encoder. So they have this command encoder. Which I'm guessing is a way that you can like execute a couple of these, sort of like a setting up a class, I guess. If that tracks at all. So how is this used? Maybe it was wrong. Maybe this doesn't need to be a fragment, and it should be a vertex. If fragment is the thing dictating the color of a pixel, I could potentially do these based on a vertex. So this is like rendering a blue color, yeah. And it is taking a color, and we're setting a pipeline, and then that render pipeline is coming from, oh, hi Kitty, you're coming to say hi. The render pipeline is doing the vertex state and this fragment state. So fragments are very much based on colors. I mean, theoretically, all I really care about is like coloring a specific pixel, eh? So if we just want to render a bunch of pixels, like render everything the same color, Could I literally just set like the vertex to be a full square? So there's the built-in vertex index in vertex index. Oof. So the I feel like I'm starting to get an idea of like where if I need to do specific, like, I was gonna say compute, but there's also a thing called compute shaders, so like that's kind of confusing. If I want to do like a specific thing, we have specific passes and there are reasons to do certain work in certain places. Fragment seems to be very much related to the color. If we look at the old ones, our draw was doing a vec4 for, I guess that's specifically for this. What's a 111? Maybe that's white. Maybe this is actually setting the color for, that the void directly. This is calculating the actual like drawing of it. So what is a vec4? What can a vec4 return? Or what, I guess, what does a vertex shader return? Maybe that's a better way to say it. Yeah. So you can use buffer to store the vertex data. All vertices will have a position and a color. So why do a fragment shader? Why do a fragment shader even? If you can do all of the work in a vertex. So if we have a vertex, this sets the color of the current fragment to brown. Okay, so the location 0-bit tells WGPU to store the vec4 value returned. Location 0. So if we say, let's think about color specifically as the fragment, vertex is going to be the actual return. So then what we would want to do here is that this isn't actually like if we want this to return, I think we actually do want this as the fragment. I'm changing my mind here. That's going to be a fragment because that's going to determine the color. So then this will be this and this and this, because then we get a location and then we can do this. And that should make this little bit easier because we have a fragment, and then we have the vertex shader, and then we've got draw, and then we do need the buffers still because we got rid of the position. In which I think I'm going to go ahead and just copy it again back from here. Main. Now we're starting to get familiar with it a little bit, so it's easier to grab pieces that we need. The vertex buffer layout. What did I grab there? Okay. So it should just go like this. And that's going to be in the location 0, since that's what we are referencing here, location 0 for the position. That's going to return a location 0 vec4. Which is interesting. Vertex passes into fragment. So vertex determines a thing, which is color, and then the fragment is the thing that actually does the color. So if we would say color, I mean, can we just say return color? Is that going to be sufficient? Okay. A vertex shader must include the position built in and its return type. Vertex shader must include the position built in. Yep. And that that looks like this. And this is returning to vec4. Okay. Multiple entry point IO attributes. Main VS. Main VS. I think we do need that built in. Okay. The fragment input at location 0 doesn't have a corresponding vertex output. Interesting that fragment goes into vertex. I'm not 100% certain if that's what we're supposed to, like, is this what we're expecting? Okay, let's take a look at this one again. The vertex takes in location 0, 1, 2 slots, and it returns a built-in position vec4, which is some things. The main FS takes a location 0, or no, takes nothing and then returns a location 0. So the let's do this first. And that should give us white. And we are doing a we're doing that. Let's just see if we can get to some sort of baseline and something actually drawing, and then we can tweak from there. Okay, vertex buffer slot 0 was required by render pipeline, but is not set. Okay. buffer slot 0 there is required by render pipeline, but it's not set. So slot 0 needs to be set, which I'm guessing is something here. We're not sending the vertex buffer because we removed that because we were trying to do just a fragment shader. Okay, so we have no errors, but nothing actually drawn. So now if we do something like 0.5, do we get any change at all? Let's go ahead and run Naga on it as well. It does validate. So if we would do literally just like copy and paste this, we should get something to render. Let's just comment the whole thing out. Let's see if it actually renders just this, because the compute is going to determine the change. Main VS is not present in vertex state. Ooh, what? Because it has those extra ones. Particle velocity. I mean, we don't care about the angle. So like if we just say I only really care about the position. And we do this, and we do this, and we do this. This should give us a position, a 0, and a 1. Got something rendering. Okay. So now, if we change this to like 0.5, and we rerun this again, it's a different color. Okay. So that leads me to believe that this should be fine. Which is what we had before. Okay. And now this is rendering a vertex. It's rendering a vertex. And there's no computes. So it's not moving. So it is rendering specifically just that vertex at this position and 0 and 1. So if we would change this to like 0.5, what are we looking at? I guess the thing that's okay, so bigger triangle now. If we what does this vertex shader look like? The vertex. What would be a good example? Where can we look for this? So like if we look at this one, we have a vertex shader. We are setting it out, and that has a clip position, and that's a vec4. So it seems like it is definitely requiring Vector types such as vec4 are generic. Currently, you must specify the value, type of value the vector will contain. Thus, a 3D vector using 3D coded floats would be vec3. We will create two other variables, x and y. So it seems like we need at least a vec3. So I don't know what is, like, if we make this 0, what is that going to give us? I'm assuming the first two coordinates are x and y. And if so, what's the next two? We must be defining those. Okay, so it's huge. We are saying set the vertex buffer to be bounds. And then draw. And we're giving it vertices. And we're giving it instances. Let's look at this pipeline quick. The render pipeline takes a buffer and a fragment. The buffer has that and that. What is this layout? Let's go all the way back to the layout. Oh, wait, vertex. Wait, where do we set up that? Oh, render pipeline layout. Okay, layout. We are describing it with a label. Create render pipeline with empty bind group layout. Okay. So the vertex is vertex buffer data. Buffer for the 3 2D triangle vertices of each instance. So 3 vertices would be 1, 2, 3. Buffer for all particles data of type position, xy, velocity, xy. So we are making instances. So a lot of the work is happening in these buffers. Does that end up getting work group count number? So we get a vertices buffer and a render pipeline. So that vertices buffer is what we set up here. And then it particle buffers. So this is all particle buffers. So I think we could actually comment this stuff out and then it wouldn't do anything. Like we wouldn't have any issue with it. So here we're setting a vertex buffer, and that's specifically for what's interesting here is we're setting a buffer for the 3 2D triangle vertices of each instance. So what's it setting? Are these all location attributes? So like negative 0.2. And that ends up being what we pass in. So that is what's dictating this vertices buffer slice bounds. So we're setting the vertex buffer with that. So what does that mean for how we want to interact with it? When we have a vertex and we're just returning its position, and then 0 and 0, why is it a vec4 versus a vec3? And it seems like we can only use, it has to be at least a vec3. So if we're doing a slice, only a portion of this buffer for a given operation. Okay, so it's using the rest of the buffer. Do we... Only a portion of this buffer for a given. Choosing a range with no end will use the rest of the buffer. Using a totally unbounded range will use the... Okay, so we're giving it dot dot, which I believe is the entire buffer. Which feels kind of weird. Like, why not just do this? Like, why do we need this slice in there? I mean, I guess it's to convert it into a slice. Yeah. Oops, sorry, kitty. So we're setting the vertex buffer pipeline, and then the vertex buffer is created here, and we're using the bytes of vertex buffer data. And it's doing vertex and a copy. Allow a buffer to be the destination buffer for a copy buffer 2 and texture stuff. So I guess the only question here is like, why is it 6? Why is it an F32.6? And if we look at this, the vertex is doing, like, what if we just do this? What if we do a vec? So like color vec, yeah, what happens if we give it a vec3? So position must be vec4, and I think that's because we've defined it as a vec4. No, it's a vec built-in position vec3. This position is a vec2 though. I mean, that could very well be. I was getting confused there, maybe. Okay, store type of built-in position must be a vec4. And it looks like it's not validating correctly, so if we would run like Naga on it. Entry point main vs at vertex is invalid. Built-in type for position is invalid. So where is position coming from? So I guess vertex has to be a vec4. If we say vertex shader vec4, what's in there? The book of shaders. 4-dimensional flow. Okay, yeah. Not helpful. It's not. The fourth component is automatically expanded to 1.0. That might be GLSL. So a 2D coordinate is going to be x, y, 0, 1. So 0 would be the z. And what is w? If you pass a 3-dimensional vertex attribute pointer to a 4-dimensional, GL will fill in w with 1. So what's that last arg? Okay, so it fills it in as 1. That seems to be pretty clear. And that was the one that if we changed it to 0, so if we go like 0.1, what is it actually changing? It's bigger. So why is it a vec4? What is that last number doing? They gotta say it right here, right? They're not gonna say. We want to use the vertex clip coordinates. Okay. Vertex types. So this is potentially something too. See the there's the XC over, is that W or is that can't remember what that character is called now. Wow. Whatever. The W thing. That might actually be why it's that F32.6. The location 0-bit tells WGPU to store the vec4 value returned by this function in the first color target. Okay, so the fragment is technically optional. We need it if we want to store color data to the surface. So we can do strictly a vertex and we don't have to do a fragment. Interesting. So if we would actually go in here, is it gonna complain if we would remove this? Okay. So if we do everything as a vertex, it seems that we're fine. So if we would take this away, and that still seems fine. I'm assuming it's gonna render it, but it's just gonna render it black. Interesting, so it is still looking for it. Oh. Because it's still defined there. Missing field fragment and initialized descriptor. So 138 is missing fragment. So we're using render pipeline descriptor. So we can't completely remove it. So if we say like fragment sum, can we just do an empty one like this? An argument of type fragment state is missing. I guess we need to refer to it there, but if we remove it, it's not going to complain. That's, I think, what it's saying. So we still do need to say, hey, like look for one there. But if we're wrapping it in sum, it's going to say, okay, well, it's fine. It's, oh, okay, doesn't exist. There must be something that is effectively like requiring me to do it. So this definitely is adjusting the color just for this specific shader. And that's interesting because the like if we look at this main one here, we were setting a color and then we're returning in the vertex that color. So if we want to use a fragment to do the color, how would we go about that? The fragment shader, so like here they're doing draw 0 to 3 and 0 to 1. That's setting the vertices and instances, and it draws the primitives from the active vertex buffer. So we want to draw 0 to 3 vertices and this many instances. So if we would just say like, let's do one instance. Can I do 1 to 1? Are we gonna even get anything to render there? I mean, we already have an error, but. Yeah, so it's definitely not complaining about that, but it's not rendering anything. So if we do 0 to 1, we should get one render. And it might be actually that we had a lot there and there were many instances of it. They were just on top of each other because we're not adjusting the position data anymore. Yeah, so we see that. So we get one instance of this vertex that we are rendering. So now, how do we map this? This is returning specifically the this is taking that vertex and so like if we did this as 10, this is going to be very small and position should still be right in the middle. This is like determining all of the colors.
Oh, that cough came out of nowhere. Well, I was definitely hoping that I could get this finished up today, but I'm thinking we might end up needing to call it here. Let me just double check here real quick. Okay. I think we need to differentiate between the fragment and the vertex a little bit. I feel like we're really close, and this is just getting into understanding how these like shaders come together. Do we go further on this? That's the question, at least on stream. I still do want to replace some of this. I'm thinking that what we do, I feel like I'm really close, and there's just a little bit of a misunderstanding or an issue with understanding how some of these pieces come together. And some of this has to do with the way we went about it. We jumped right into a deeper example, and we've been like ripping apart. I feel like I have a pretty decent understanding of things now, but there's just a couple dots that we're missing the connection of. It would be cool to change this background and have that be something that is reactive. And I would kind of like to get into shaders a little bit more, especially shaders in the background, you know, like browser source WASM type things, but also just straight up shaders and using Naga. And now that we have a little bit of an understanding how Naga is working, we can check that out relative to like what does it look like to include a shader directly in OBS. I am curious performance wise, like how is it gonna, like what does it look like performance wise with one implementation versus another? I'm assuming if we do the shaders directly through OBS, which might require a different format, a shader format, I'm assuming it'll be more performant. But that caveat there is that we might have less reactive control over it. So we could do something that's sort of a looping thing, which is kind of cool. And it would be reactive potentially to like my camera or my movement, but it would be reactive to chat or interaction, be interactable in that way at all. So I think we still do want to explore some of that. Now we might do a stream strictly on just shaders now that I have a little bit of a better idea of how Naga works. Maybe a stream on shaders with Naga in OBS. That might be kind of cool. If we can use that to like validate it and check it, that might be helpful. And we could throw together a quick shader that would just be like a camera thing, and that might be something that'll be fun to give a shot. But a separate stream from that might be making something like the background here reactive to chat or events. And that might tie into other stuff later on better, where we could, because we would want to look at how do we communicate within this Rust WASM thing to outside. So JavaScript or if we're in Ataria, like a background there. So I think this is where we're going to set it down for now. I'll probably try to get this working. And when we come back around and we start getting into the how do we make this reactive to like chat or outside communication from WASM. We might set this down for a little bit and come back to it. But I think that's where we pick it up. And we pick it up there, and we can, hopefully this is not that big of a deal to fix. And if it's not that big of a deal to fix, we can just kind of go over what needed to change then to get it working. So you'll know that I got it working, and it's potentially in the docket to come back to it when the background changes. But I feel like we're real close. I think we understand the compute, and then the render passes. The compute seems to be the thing that determines movement and the position. So even if we got the vertex and the fragment shader working, it's not gonna move. So we might still need to do stuff with the compute. And yeah, that's where it's just get involved. So I think this is gonna end up being something that I finish up off stream, because we've spent a good amount of time on it, and we've dug into it enough that I feel like from a specific content perspective of digging into this, I feel like we've hit on everything. We're getting into real niche too, so let me know how y'all are thinking about this. Like, is this something that you're finding interesting? I feel like we're getting in a real niche where there might be a few people out there that are getting value from this. But we might want to like shift up the stack a little bit for a few streams here. So we're gonna call it here. We'll see what we can do when this background changes for all you few people that have gotten to the end of this niche topic. You'll see the background change, and it's gonna be between us. You'll know that I finally figured it out, and we'll come back to it and see if we can make it reactive. So we have a potential few topics there, but next week I think we're gonna look at something else. Let me know in the comments if there is something that you want to see us go through on stream. We might do, I don't know if I'm ready to jump in to Tau and Rai quite yet, but maybe soon. There are potentially other little Rust things though that I might want to do, so we'll see. Drop a link in the comments if you want to, if we want to go over any specific crate or whatever JavaScript thing as well on the stream. Hit that subscribe button too, so you get the notification when we do go through it, and we'll go from there. So we're set down this topic, and we will see you next week on a new topic. Bye.